Hello, I'm Andy Peel from the CCDC, and welcome to this video on how to search and visualize 3D structural data using WebCSD, the online platform of the Cambridge Structural Database. In this demonstration, we will see how to draw a substructure query and how to add 3D parameters with constraints. We will then explore the features and information available on structures from the results page. We begin by navigating to the Access Structures webpage. You can access this directly by typing the address www.ccdc.cam.ac.uk/structures into the browser, or you can go via the CCDC's website, or simply search for CCDC Access Structures in a search engine of your choice. Here is the main Access Structures page. If you can't access the Structure Search tab, you may need to contact your site administrator for help. Clicking on the Structure Search tab, you can see the sketcher. OK, so let's begin by adding an aromatic ring. To do this, you click on the arrow next to the two ring templates and then scroll down to the bottom. Hovering over it, it says 6 aromatic ring. If you click that, then you'll see that this aromatic ring hovers over the mouse cursor position in the drawing area. I'm just going to click that once, and then I'm going to change one of these atoms to be a nitrogen by clicking on nitrogen in the left-hand menu. Then, clicking on an existing carbon atom of the benzene ring will change the element to nitrogen. If you make a mistake, you can always do Ctrl-Z, which will undo that action. Now I'm going to add a second aromatic ring up here, leaving plenty of space in between that and the other aromatic ring. In this case, I want to add an iodine atom to the aromatic ring. To do this, I'm going to bring up the periodic table from the bottom of this toolbar. You can select groups of elements or individual ones just by clicking on each of them, so I'm going to select iodine. You can then move the periodic table out of the way or close it. Next, you click, drag and release to attach an atom by the currently selected bond type, which is single. Now that the substructure is drawn, we can add some 3D parameters to the query. To do that, you go to the Add 3D button on the left-hand side and click on it. That will bring up the Add 3D menu. You can see from the options down here that you have several different possibilities. At the moment, these little plus buttons are greyed out, and that's because you need to select some atoms first to be able to define the associated parameters. To do that, you press Shift on the keyboard and left-click on the required atoms. In this search query, I want to constrain the distance between the nitrogen and iodine atoms to a maximum value to look for potential interactions between them. Having selected those two atoms, you can click plus next to distance, and you'll see that at the top there's a little slider that gives you the option to constrain the distance. Click on that slider, and then you'll see that you have three options. These are any, intramolecular or intermolecular for non-bonded contacts. In this case, I want to look at the intermolecular ones, so I'm going to select that, and then you'll see below it that there are low and high limits for the distance. The low limit we can leave at 0 angstroms, but the upper limit we will change to 3.5 angstroms before clicking OK. Once you've done that, you'll see that the distance is given the name dist_1 in this section. It summarizes the atoms that are involved in that measurement, and on the right-hand side you have the options to delete the measurement, edit it, and turn on and off the visualization of it in the sketcher. We can now close the Add 3D dialog down. Next, we move on to select the search type. In this instance, we want a substructure search, so you need to make sure that substructure is selected here, and then press search. You can see as the search is running, we've got this progress bar at the top, which is reporting the number of structures being found, and you can see that we have nearly 800 results. This number will likely be different if you try this search yourself on account of the continuous updates to the database. We can scroll down through the list of structures until we find one that we're interested in. This one, ref code AREJOZ, looks interesting. At the top of the page you can see there's a summary including the ref code, the chemical name, space group and unit cell. Underneath this there is the 3D viewer that we'll explore a bit more in a few moments. And there is a chemical diagram on the right hand side. Notice how the bits that match the substructure we drew are highlighted in brown. You can actually turn on the same highlighting in the 3D viewer with this little highlighter pen symbol. Underneath the viewer there are some details about the data itself. There's a deposition number, a data citation and the date of deposition. Underneath that there are some details about the crystallographer, and we have a link to the publication that this structure is associated with. Next there is a summary of the chemical formula, some details about the crystal, including its habit and colour, and then some details about the experiment, including the temperature that the experiment was done at. On the left hand side, right at the bottom of the list of results, which you'll notice paginated because of the large number of hits, you have the option to download the current entry, all of the entries from the results that we've got, or to download a GCD file. This is a file that can be opened by the program Mercury, which is the CSD structure visualization software. You can also download a TSV file containing the list of measurements of 3D search parameters. In the present case, that would be a list of the iodine to nitrogen contact distances that were specified in the substructure search. Just going back to the 3D viewer, you can scroll the mouse wheel to zoom in or out on the structure, left click and drag to rotate the structure, and right click and drag to translate it. At the top you find the options to change the model style. Currently it's set to ball and stick, but you might want to look at capstick or perhaps wireframe when looking at pack structures to make the view less congested. We'll put the style back to ball and stick for the moment. You can choose to label atoms in various different configurations. We might want to label just the halogens and nitrogen atoms, so we could choose all but C and H, or you might want to label all the atoms using that option. I'm just going to turn off labels for the time being. Other visualization options include toggling on and off the hydrogen atoms. If there's disorder present in your molecule, then you can also use this disorder button to toggle that on and off. We don't have any disorder in this structure, so that's not something we need to worry about. You can set your molecule rotating using this play button over here, and you can view the pack structure using the drop-down menu next to it. There are a few options, so you might want to look at the unit cells worth of content, or perhaps a 3x3 array. You can see this might be an instance where the wireframe style is particularly useful. I'm just going to return to the default view using the reset button at the top. Other things you might want to do are to measure distances, angles and torsions. So for example, we might want to see what the nitrogen to iodine distance is. If you click on a particular atom, it becomes highlighted in this translucent green sphere. If we do that to the iodine as well as nitrogen, then you can see that this distance measurement tool at the bottom right hand side becomes activated, and if you click on that it will report the value. You can see that it's below the 3.5 angstrom threshold that we set. Lastly, at the top of the visualizer we find a button to download a Mol2 file. This concludes the demonstration of WebCSD. If you would like more practice using WebCSD, check out the resources linked in the description. Thanks for listening, and don't forget to subscribe to our YouTube channel.